Okay, so we're talking about proportions, but before we can really talk about a proportion, we have to understand what a ratio is. The reason why we have to understand what a ratio is because a proportion is made up of two ratios. So on your note sheet, under definitions and ratio, a ratio is going to be a comparison of two quantities using a fraction. Okay, and we talked about that briefly yesterday when I asked you guys to give me a comparison of two numbers. You guys could compare like boys to girls, students to teachers, blue eyes to brown eyes. Those are all comparisons. So where it says definitions, ratio, you need to write down a comparison of two. Quantity means numbers, okay? So a comparison of two quantities using a fraction. Yeah, okay. So then after ratio, we have proportion. A proportion is basically when two ratios are equal to each other. So a proportion is made up of two equal ratios. So it's not just any random two fractions. They have to be two fractions or two ratios that are equal to one another. So the first thing that we're going to do today on your note sheet is learn how to identify if proportions are equal. Then the second thing that we're going to learn today is how to solve for a proportion when we're missing a number. You guys already know, you already have the skills to do this entire lesson though. So the only thing that you're really learning today is the necessary steps of putting it together to get your answer. Okay?
Hi, everybody.
All right, we have it down? Okay, if you don't have it down, I'll come back to it at the end. Just remind me. If I see that, it's mine. Hernandez. Okay, so determinant of two ratios or proportion. Two ratios are proportional if what? Two ratios are proportional if the fractions are equal. So two ratios are proportional if the fractions are equal. Okay, so definitions and stuff like that, when I'm just having you define things, doesn't really mean anything to me unless I have like a visual example. So example 1 and 2 on the front side of your note sheet here is going to give you an idea of what I'm talking about. We're going to look and see what two ratios look like. We're going to look and see what a proportion could look like. And we're going to see an example of a proportion. Okay? So example number 1, you have 3/4 and 6/8. So this sign in the middle is just an and sign. I can't draw that. If you want to write the word and out, you can write the word and out. If I do my and signs like a little loop like this, however that you want to show 3/4 and 6/8 is fine, okay? If you can't draw this and sign, totally fine. Okay, so Alex is jumping ahead of me here. So what he's talking about, this is a ratio and this is a ratio. We need to determine if these two ratios are proportional, meaning do they equal each other? Put your headphones up.
Yeah,
There are 3 different ways in which I can determine this. One way is what Alex said. Don't we just take 3 times 8? And then what, Alex? So what's 3 times 8? Okay, 24. So if I take 3 times 8, what's the other way that I'm going to have to, what's the other part I'm going to have to do? Which is? Okay, so are these two numbers the same? Yeah, so that means that these two ratios are proportional, so yes. So how did Alex how did Alex determine if these two ratios were equal, if they were proportional? What method did he use? Yeah, he cross multiplied.
3 times 8 and 4.
So, like AJ just said,
And
cross
it's
multiplying. Cross multiplying is one way that you can determine if ratios are proportional. There are two other ways that you can also tell if a ratio is proportional. Anybody else have a guess of how you can determine if these are proportional? Say it again. Divide. So AJ, when you say divide, what do you mean? Not divide across, but
We should just divide like 4 and 8. Can you do that?
no.
Miss Lincoln,
Are you going to answer my question?
what is it?
So one way that we can show that these are proportional are by cross multiplying. Another way we can show that they're proportional, AJ gave us an idea, we're going to divide. But what are we going to divide? Do you have an idea?
Wouldn't it be like 24 divided by 2?
No? AJ?
What?
No?
Wouldn't it be like 6 divided by 4?
No?
No one
So
uses
let me help you out here. What you could do is change each fraction to a decimal. So how do I change a fraction? Hey, Kaylin, I'll take that. How do you change a fraction to a decimal? How do I change a fraction to a decimal? Good, AJ. I divide my numerator divided by my denominator. So I'm going to take 3 divided by 4. When I take 3 divided by 4, what does that equal?
3 divided by 4 is
0.75. So then I also need to change 6/8 this fraction to a decimal. So what's 6/8 changed to a decimal?
The same thing.
Are you sure? You type it in?
6 divided by 4.
6 divided by what?
Ain't 6 divided by 4?
No, what's this?
Oh.
8. And it's the same thing. So again, 0.75, 0.75, they're the same things. So that's another way that you can show it's proportional.
If it matches, it's yes. If it doesn't match, it's no.
Correct. Good, Mike. The last way. So you have two fractions here, right? A way that you can check to see, the final way that you can check to see if these are proportional is simplify each fraction. So you're looking here at 3/4. Is 3/4 in simplest form? Type in your calculator. Type
Yes,
in.
it is.
Yes. So is 6/8 in simplest form?
No.
No. What is it in simplest form, Mike?
3 over 4.
So if we divide each of these by 2, we're going to get 3/4. Is 3/4 and 3/4 the same fraction? Yes. Now, am I going to make you show each of these ways every single time
Yes, because
that I
it's
want you to
flexible.
see
It's work-
if it's proportional? No.
Good.
You only have to show me one way. Now, the way that I would recommend is cross multiplying. It's the quickest, in my opinion, it's the easiest.
I'm done with X1. Multiply.
Okay, let's take a look at example number 2 here. Let's take a look at example number 2. So again, you have two fractions or two ratios. It says determine if the two ratios are proportional. So you can choose to either change each of these fractions to a decimal, you can choose to reduce each of these fractions, or you can choose to cross multiply to determine if these ratios are proportional. Like I said, I like to cross multiply, so I'm going to cross multiply here. When I cross multiply, it does not matter if I start at the top here or at the bottom. You just have to make sure that you go across. I always like to start at the top, so I'm going to take 20 times 40. What's 20 times 40 equal? 80. We sure?
It's 800.
It's 800.
Okay. So then we're going to take 44 times 24. What does that equal? Bless you. Huh? 1056? So are these two numbers the same? So if these two numbers are not the same, then they're not proportional. So that's how you would show your work for that. Okay?
Oh, we gotta put a note.
So show, well, you don't just have to put no, you have to show me why it's no. Okay, so let's say you chose to change them to a decimal. Well, you'd have the two different decimal numbers to show that they're not equal. They're not the same. Oh, wait. Once you're done with that, go ahead and flip to the back. Now, the back side is really going to be our main focus. Okay, this is the type of problems that you're going to see on your worksheet that I'm going to hand out today. So, we just talked about this. In order to solve a proportion, we're going to cross multiply. So in order to solve a proportion, we're going to cross multiply. Now, if I have a proportion that's missing a number, think about like what we did in our notes yesterday. After we cross multiplied, what did we have to do? So when we had our stuff yesterday, we'd have like a percent over 100, an x over 25. So we would cross multiply. Then after we cross multiplied, we had to do what?
Oh, they do that. What's that we used to do?
Yeah, solve. So then we had to solve. So cross multiply, then solve. Okay. So cross multiply, then solve. Ooh, that's really ugly. There you go, Mike. Fixed it just for you. I fixed it for Mike.
Yeah, I used
Well, good.
That was a bad VE, wasn't it?
Yeah, it's a bad VE. Sloppy handwriting on the screen.
Okay, let's look at example number 3. So example number 3, it says solve for the variable. So we're going to have to determine what number that variable represents. Once we determine what number that variable represents, we should have a proportion. Okay? So, first step in our notes, it said to cross multiply. So I'm going to cross multiply. 2 times 6 is 12. Then I cross multiply 3 times a and get, so 12 equals 3a. So there I cross multiplied. Now I'm ready to solve. It's a one-step equation, as you guys told me. So I'm going to circle my variable. I'm going to draw my line of equality. I am going to look to see that you guys have circled your variable and drawn your line of equality. To get the variable a by itself, what do? Divide by 3 up both sides. So whatever I do to one side, I do to the other. That cancels. 12 divided by 3 equals?
36.
12 over 3 equals? I heard it. 4. So 4 equals a. So, what that basically means, you don't have to write this part that I'm going to write now in the red. Don't write what I'm writing in the red. But basically, if I have a ratio 2/3, and I have another ratio a over 6, well, what did we say a equals? What did we say a equals? So if I substitute that 4 for an a, and I want to make sure my answer's right, I can check to see if this is a proportion by cross multiplying. So what's 2 times 6? Okay, and then I'm going to cross multiply 3 times 4. So they're the same, right? So then we solved it correctly. Don't have to show what I have in the red, though. So basically, this right here, this is it. You think I'm going to keep it this easy? Yes. Oh, no, we'll find out, won't we? All right, example number 4. Example number 4. So we have 20 over 24 equals C over 12. Okay? Now, when Mr. Betts solves these, he likes to always cross multiply where the variable is going to be present first. He likes to keep that variable on the left side. To me, it doesn't matter. So you can either start with the 20 or you can start with the 24. So Kaylon, do you want to cross multiply, start with the 20 or the 24? Okay, so if Kaylon's going to start cross multiplying with the 24, what are you going to multiply together here, Kaylon? Okay, so he's going to do it Mr. Betts style. So he's going to keep the variable on the left side. What's 24 times C? Yeah, 24C.
Yeah, 24C. I'll do 20 times 12.
So then he's going to cross multiply. So 24C equals 20 times 12. What does that equal?
240.
Now, let's say that you did it the way I like to, where you started at the top to the bottom. It's okay. So let's say that you took 20 times 12 first and you got 240. Then you took 24 times C and you got 24C. It's okay. You're going to end up with the same answer, except for your variable and answer will be on opposite sides. All right? You're going to follow the same steps. You're going to still get the C by itself. So let's go ahead and solve here. So I'm going to circle my variable. I'm going to draw my line of equality.
The answer is 10.
I never just want the answer. To get the C by itself, I'm going to divide by 24. That cancels, so then C equals 10. Box your answer. So if you did it, if you cross multiplied with the 21st, you're going to get the same thing, except for it will look like this. It means the exact same thing. Okay? Does not matter. All right, we're going to move over to example number 5. I think this is my favorite one.
Why? Because it's so hard for us. Come on,
I don't know. What do you think?
Yes. Yes, it is.
Okay,
So hard.
so what's different about this example compared to the other ones I've given you?
You have a B so far.
Yeah, you have a variable and a number. Does anybody have any guess on how you would solve this?
You can't cross multiply things?
Yeah, we're still going to cross multiply. So, Daisha, what number do you want to start with cross multiplying? The 2 or the 3?
Can you just write it for us? That'll be great.
The 3. Okay, so Daisha's taking the 3 times 6 first. Oops.
18.
Sorry, hold on. I didn't have my pen on.
Of course you can.
So, she's going to take the 3 times 6 first.
Equals 18.
Equals 18. So 3 times 6 equals 18. Okay? So the other way that I'm going to have to cross multiply, the other numbers I'm going to have to multiply together is 2 times, what is this here? B plus 5. So what that basically means, I'm going to have to take 2 times that B plus 5.
Yay.
So there's 2 ways that you can write it. One, you can write it like you're distributing. So you could write it as 2 times B plus 5. So you could write it like this. Or you could write it as 18 equals, okay, what's 2 times B? 2B. Then, after you take 2 times B, you're going to have to take 2 times what? What kind of 5 is that? So what's 2 times positive 5?
10.
So plus
So
10.
what's the 10 be?
Nope, just 10. Okay? Can you combine 2b plus 10? No, because they're not like terms. So, I prefer to do it the way that I did in the red, because to me, it's one less step I have to write out. Because if I write it out like I did in the blue, then I'm going to have to go back through, distribute, to get what I got in the red, and then solve. So I just prefer to solve it from the very beginning like that. So now, what kind of equation is this? Two-step, yeah. So it's a two-step equation. We're going to follow the same steps. Our goal is still to get the b by itself. So what do I get rid of first in order to get the b by itself? Negative 10. Nice. Minus 10, yeah. So my positive 10 cancels with my negative 10. 18 minus 10. Then I bring down my 2b. How do I get the b by itself? So then b is going to equal 4. And box it. Good. Nah. Honestly, that's the hardest it's going to get. Okay?
I knew it was your favorite.
That's the hardest it's going to get.
It's the last one, Doug, for us.
The last one is yours. Cody, you got to get these down, bud. You're going to have to copy it down from...
Hold on, let me do 26.
Go to the next one.
I'll give you 10 seconds.
Alright, 1098 seconds, 6 5 4 3 2 1.
Oh, that's not how you count seconds. 1 Mississippi, 2 Mississippi.
Yeah, Mississippi is a state, and you're
Or it could be a what?
and you're gonna use your voice by.
Okay, here we go. Last example. Now, when you look at example number 6, the directions are a little bit different. Read the directions for me here, Danielle. What? I'm old and I'm deaf and I can't hear. What?
Then how if you're
I can hear your big mouth, don't worry.
and I can see your big face. That's it.
Are you going to read this to me?
You got a round?
Kaylin, help her out. She's like, I'm over this for today.
Solve the variable round to the nearest stop.
Yeah. So this time, when we solve, we're not going to get a whole number. Means we're going to get a number with a decimal. Alex, can I help you? Have a seat. No. When do we ever get up in the middle of class and just start walking around? Yeah, no. You stay in your seat. So we're going to solve for the variable and round to the nearest thousand. Basically meaning when you go and solve this, you're not going to end up with the whole number. You're going to end up with a decimal. How many places past the decimal to the right is a thousand spot? 3. Good. All right. That would be 10,000. Okay, here we go. First thing we're going to do, cross multiply. So when I cross multiply, what's D times 7? 7D. Good. Always put your number first, then your variable. Then I'm going to cross multiply. 6 times 5? 30. So I cross multiplied. Now I'm going to solve. I'm going to circle my variable. I'm going to draw my line of equality. How do I get the D by itself?
Divided by 7.
Divide it by...
Yeah.
Yeah. Okay. Now, in Khan Academy and our past assignments, when we had a fraction or a number like this and it wouldn't divide out evenly, I just had you guys keep it as a fraction in simplest form. But because my directions say to round to the nearest thousandth, I know I'm not going to do that. I'm going to go ahead and divide it out. So when I take 30 divided by 7,
It's like 0.
what do we get?
It's 0, 2, 3, 3.
No. 4 point, don't touch that. 2, 8, 5, 7, 1, 4, 2, 8, 6. Okay, now you can touch it. Okay, so Alex already told me if we're going to round to the nearest thousandth, that means we're going to look at the number 3 places past the decimal to the right, which is the 5. Everything else I get rid of. I'm going to use that 7 directly behind the 5 to see if I round this 5 up or if it stays the same. Looking at Alex, he says I'm going to round it up because that 7 is 5 or greater. So my final answer is actually going to be D equals 4.28. What?
5.
What? 6. And box it.